Hello students, we are solving a question on oscillations. This also involves some concepts from properties of fluids. This is from 24 January shift 1, JEE Mains 2026. The question says, a cylindrical block of mass capital M and area capital A is floating in a liquid of density rho with its axis vertical. When depressed a little and released, the block starts oscillating. The period of oscillation is. So, in situation 1, we have a simple block, cylindrical block floating inside a liquid. Let us say the portion L is inside. So, in this case, for equilibrium, the force of gravity, which is pulling the block down, must be balanced exactly by the force of buoyancy, which is pushing the block up. So, Fg minus Fb is equal to 0. So, mg minus rho A Lg is equal to 0. This gives you the mass of the block as rho Al, where L is the portion of the block that is immersed in equilibrium. Okay, so we can use this in the next portion of our solution, where we are going to depress this floating cylindrical block by x. So I have depressed it by an amount x. So once it depress it by an amount x, now the portion of cylindrical block inside the liquid increases from L to L plus x. So because of this increased volume of the submerged solid, the force of buoyancy is going to increase, but the force of gravity is the same because the mass is not changed. So force of buoyancy has increased. So net, this cylindrical block will now face an upward acceleration. Applying Newton's second law, mass into acceleration is equal to Fg minus Fb. Because I have given a downward displacement, I will consider downward force positive. That's why I have considered force of gravity positive. So if you calculate this, mass into acceleration equal to force of gravity is mg, but force of buoyancy is no longer rho A Lg, it is rho A into L plus x into g, right? Because now L plus x is submerged. So ma is equal to mg, open the brackets here, minus rho A Lg minus rho A xg. Mg and rho A Lg will cancel out. Why? Because we know they are equal. This we have known from the equilibrium condition, right? Mg and rho A Lg gets cancelled out. This gives you A equal to minus rho Ag by m into x. Look at this. This looks like the characteristic equation of SHM. A equal to minus omega square x. That means this term, which is the coefficient of x over here, is the angular frequency square. Omega square is rho Ag by m. So to find time period of SHM, we know it is 2 pi by angular frequency. Substituting the value of angular frequency, you are going to get the time period to be 2 pi root m by rho Ag, which matches with option 3.